my name is Meg Graham, and today I'm going to talk to you about coronary circulation. And what coronary circulation is, it's the actual flow of blood in the heart muscle itself. Even though the heart is full of blood and it's always pumping blood, that blood does not get down to the deep inner recesses of the heart and supply that muscle. And the muscle is very metabolically active, so it needs its own blood supply. The path of blood flow varies considerably between individuals, and you'll see some individuals, they may have one coronary artery, most have a right and left coronary artery, and then different branches off of those, but the paths can vary considerably, so I'm going to give you just the most common path that you'll see in individuals. There's also a lot of different anastomoses or junctions between vessels, and those don't always follow a pattern. So there's a lot of little intricacies that are not quite the same in everybody, but I'm just going to give you a good general path of flow of blood. You also have collateral or alternate routes that form in some of these vessels. So if you're getting a little blockage somewhere that's not serious, you might get vessels developing that will kind of move around that blockage and help flow. But if you have a major vessel occluded, you've got problems. So let's talk about about 1/20th of the total blood supply. So even though it's a tiny organ, it actually requires a large amount proportionally of the blood supply that's moving around the body. Blood only flows through the coronary arteries when the heart muscle is relaxed. So when it's contracted, it's going to be compressing those arteries, and they're not going to be pushing blood around. So it only is going to get through when the heart muscle itself is relaxed. That's when the blood's going to flow through these arteries. And the left ventricle is going to receive most of the blood flow because that's the thick major portion of the heart that has to pump blood to the rest of the body. So that's going to be the most metabolically active part of the heart, and so that's going to get the most blood flow. All of these vessels that I'm going to talk about lie in the epicardium, or that outer layer, and then they send branches that go down to the inner layer in the myocardium, and then those branches go from the myocardium, they'll get smaller and smaller and get into capillaries, and then all that blood is going to have to be collected back and sent back into the right atrium of the heart. So we're going to see a circuit here. It's the smallest circuit of flow in the body, but we're going to see a whole pathway that goes. Okay, if you look at the blood flow to the heart itself, of course, when blood leaves the heart, it's leaving the left ventricle and it flows into the aorta. Well, right off the aorta, the first branches that you're going to get are the right and left coronary arteries. If you look at what's going through, and if you look at those coronary arteries, both the right and left, they're going to circle the heart. So they just kind of split the heart in that coronary sulcus between the atria and the ventricles. They're going to run in that little sulcus, or that little groove, and go right around the heart. Well, let's start with the right coronary artery. It's got two main branches. It breaks off into the right marginal artery, which is going to supply the right side of the heart, and also the posterior interventricular artery, which is going to supply the right ventricle down to the apex of the heart and all the posterior ventricular walls. If you want to look where they are, just look at the name. Posterior, it's going to be on the back side, and interventricular. Inter means between, and ventricles, obviously ventricular. So it's going to be on the back side in that little groove between the ventricles. If you look at the left coronary artery, and again, it's going to kind of circle the heart going to the left side in that coronary sulcus between the atria and the ventricles. That one also has two main divisions. The first one is called the anterior interventricular artery, and again, the name tells you where it is. Anterior, it's on the front side. Interventricular, it's between the ventricles. So it runs in that groove between the ventricles on the front side of the heart. This one is also known as the left anterior descending artery, or the LAD. And you can use either one of those names. They're both fine to use. But this vessel is going to supply the interventricular septum, that connective tissue between the ventricles, and also the anterior walls of both of the ventricles. Then you have the circumflex artery, which is going to flow around to the side, the left side of the heart, and that one is going to supply the left atrium and the posterior walls of the ventricle as well. Now, if you look at this model here, or this picture here, it's a little deceiving because it kind of shows you the front and the back of the heart. You've got your right atrium here, so let me write that on there. That's this whole little area right here. This would be your left atrium, and then this would be your right ventricle and your left ventricle. Okay? Now, the first branch that you see, this is your aorta right here. So there's aorta, and coming off of this aorta, you've got a branch that you can see. It's behind this vessel right here, so it looks light colored, but that's your right coronary artery. Notice it comes down, and in the front of the heart, it's going to break off and go down like this. So this is all considered right coronary artery, and then it branches right here. Okay, so that's your first major branch. This branch coming down this way is going to be your right marginal artery. Okay, and then this keeps circling around on this side, and it's going on the back side of the heart. So if you look on this picture, all of a sudden these vessels right in here start getting light colored. Well, that's this branch circling back around. So it circles all the way around to the back side of the heart, and then it comes down on the back side of the heart in between the ventricles. So this is going to be this posterior interventricular artery. Don't you wish you could write as neat as me? I don't have too many talents. Okay, so then if you go to the left coronary artery, that again is going to be coming off this aorta right here, and it comes down like this, and it's going to branch a lot quicker. So the first main branch coming down the front of the heart here goes right in between the ventricles. That's going to be that left anterior descending coronary artery. It's also known as the anterior interventricular artery, and that might be the easier way to learn it because it tells you exactly where it is. Anterior on the front side, inter between ventricles. So that's that anterior interventricular artery. And then the other branch of it goes around to the back side of the heart. It circles around. So we call that the circumflex artery. Okay? And this circumflex artery goes all the way around to the back side, so it just kind of circles it. So those are your main arteries. Now, that's going to bring oxygen-rich blood to the heart. So those arteries will go deeper into the muscle, and they'll develop into arterioles and eventually capillaries, and that's where you're going to have gas exchange occurring. And then you pick up the CO2, and you want to bring that back to the lungs, and back to the heart. And so now we've got to look at the venous flow of blood in the heart. So if you look at that, one thing you need to remember is all of the veins are going to flow up to this one major vessel called the coronary sinus. And that coronary sinus sits on the posterior side of the heart, and it's a big bulging vessel. It's kind of ballooned out, so you can't miss it if you're looking on the back side of the heart. And that's going to be where all the veins drain into. And then that coronary sinus is then going to drain into the right atrium. So you've got all your main vessels, the great cardiac, the middle cardiac, and the small cardiac vein. They all come down and they go into this coronary sinus, which then drains into the right atrium. Now remember, the right atrium is going to be accepting oxygen-poor blood and carbon dioxide-rich blood so that we can take care of all those gases and get rid of them in the lungs. Now, the great cardiac vein is going to be real easy to figure out because it runs in that anterior interventricular sinus. So let's go ahead and look at a picture of this. So again, this is the heart, and you're looking at the anterior side, but these light-colored things like that, that's your coronary sinus. That's on the back side, so you're kind of looking through the heart to see that. But that would be your coronary sinus. But in the front, you've got this anterior interventricular sinus right there, or sulcus, excuse me, and that's where your great cardiac vein is going to run. So I'm going to write that down here, right there. So that's going to drain the front of your heart, basically. It's taking all that oxygen-poor blood and bringing it from the front of your heart. Then the next major vessel you have is on the back side. So notice this starts going around to the back side of the heart, and if you kind of follow it around in the light-colored picture here, on the posterior interventricular sulcus, you're going to have this middle cardiac vein. So remember, this is on the back side of the heart. Even though we're kind of looking through the heart here, it's kind of hard to figure out. But so now you've got this middle cardiac vein that runs right in that posterior interventricular sulcus. And then finally, you have this little small vein right here called the small cardiac vein. And that one is going to drain this lateral side of the heart. So the great cardiac vein drains the front side, the middle cardiac vein drains the back side of the heart, and then the small cardiac vein is going to drain this right lateral side of the heart. And again, they all go to this coronary sinus. They dump into there, and then this coronary sinus then dumps into the right atrium right there. And that's how we get blood returned back to the heart. Sometimes, though, blood doesn't always flow through the heart real well, and you get what are known as blockages. Most people confuse these two terms, atherosclerosis and arteriosclerosis. Atherosclerosis is where you have fatty plaques and lipid deposits, and those will actually be on that inner layer of the vessels, and those cause blockages. Okay, so if you got your junk food diet, that's the kind of stuff you're going to be building up. Just think about every time you eat that chip, it's just putting a little pile in one of your coronary veins or arteries. Most dangerous would be the arteries. But anyway, those are fatty, plaquey deposits. Then arteriosclerosis is a more chronic condition where you just get thickening and hardening of the vessels, and that causes a loss of elasticity. So the vessels are not as elastic and just bouncy and springy as they should be. But it's the atherosclerosis that causes the blockages and the plaques and stuff. Now, you can have a moderate blockage, and you might just get something known as angina pectoris. That's this word right here. And that literally means choked chest. So you might feel a tightness in your chest where the cardiac muscle cells are being starved. They're not dying, they're not being killed, but they're being starved for oxygen, and they're screaming, help, and it just hurts. So you just have this tightness and pain in your chest, especially upon exercise or any kind of exertion. If you get that, you need to get that checked out. That's not a killer, but it might be a precursor to a killer. Significant blockages, though, lead to what's known as a myocardial infarction, and that's the fancy word for heart attack. And if you have a major blockage and blood flow does not get to the heart muscle itself, then it will actually kill the cells. And once those cells die, they don't regenerate. Heart muscle, mature cardiac muscle cells do not divide. So you either get scar tissue, or it's such a major blockage that it damages enough heart muscle that it actually kills you. So I think I'm going to leave it on that note that you just died, because that's probably